Hello all, we are going to be doing a problem from 4.7, number 14. 4.7, number 14, optimization. So in this problem, we have a box with square base. So we have a box with square base. That means that these angles are all 90 degrees. Okay. And open top, so no top, open top or no top. Okay. This box has a volume of 32,000 centimeter cube. 32,000 centimeter cube. The problem is saying find the dimensions of the box that minimizes the amount of material used. Okay, so in order for us to minimize the material used, that means that we need to minimize the surface area. So there are two pieces of information that we have here. We have one that's given for volume, which is 32,000 centimeter cubed. And the other piece of information is that, hey, we want to minimize the surface area. So how is the first part going to help me? So if I call this space X, this one, this side X, then this one has to be X because it's square base. So same size of sides for the base. And let me call this Y. I know that the volume, which is V equals to the area of the base times the height. And so I have 32,000, which is given, equals to X squared times Y. But the problem is talking about the surface area. What is the surface area for this box? Since it doesn't have top, then I have X to the second for the area of the base plus 4 times each side, which is going to be X times Y. And right now I do have a problem. The problem is that if I want to take the derivative of this, I do have two variables, X and Y. So do I take the derivative in relation with X or in relation with Y? What can I do? I can solve from, use this first equation and solve for Y. You see, this one tells me that Y equals to 32,000 divided by X to the second. So I'm going to go ahead and substitute that into this Y. So I'm going to have surface area equals to X to the second plus 4 times X times 32,000 over X squared. And this can be a little bit simplified. I'm going to go to the next page. So I have surface area equals to X squared plus 4 times 32,000 is 128,000. And X is canceled, so I have over X. And now that since I want to take the derivative, I'm going to rewrite this as S equals to X squared plus 128,000 X to the negative 1. That's easier for me to, take the derivative. So now I can claim that, okay, S prime equals to 2x minus 128,000 x to the negative 2. And now I know that if I set the derivative equal to 0, I'm going to find my critical values, if any. So I'm going to say 2x minus 128,000 x to the minus 2 equals to 0. Going to the next page, this gives me 2x equals to 128,000 x to the negative 2. Multiplying both sides by x squared gives me 2x cubed equals to 128,000. And dividing both sides by 2 gives me x cubed equals 64000. And so cube root of that is 40. Cube root of 64 is 4, and I have 3 zeros. So, and you know, 40 times 40 times 40 is 64,000. Okay, so now I know that is my critical point. Critical point. Okay. So the size of my cardboard starts from 0, 0 is not included, and potentially can go for a while. So, and we said that 40 is my critical point. If I pick a number to the left of 40, 30, 20, 10, and plug it into my derivative, it'll give me a negative value. A number to the right of 40, say 50, 60, 70, gives me a positive value. So I know that I do have, let me change color, that my graph is decreasing, turning around, and increasing. So I do have a minimum at 40, okay? So at x equals to 40, I have a minimum. I have a minimum. Okay, well, if x is 40, what is y? We know from that y equals to 32,000 divided by x to the second, that equals to 32,000 over 40 to the second. That equals to 30,000 divided by 1600. Okay, cancels the O's. So I have, oh, check this, this was 32,000. So 32 divided by 16, here's a 2, and I have a 0. So y equals to 20. So the dimensions of the box are going to be 40 by 40 by 20, and of course, the unit is centimeter. I hope this video was helpful. Thank you.